Good evening, students. Good evening. So last class I have started kinematics, one-dimensional motion, and we have done some problems based on uniform acceleration. Okay. And what are the formulae we can use when particle is going with uniform acceleration along a straight line? Basic formula: V equal to U plus AT. This is ut plus half a t square, and v square minus u square is 2as. 2as. Okay. Here, what is v? Final velocity. That is velocity after time t. U is initial velocity. A is acceleration. S is displacement. S is displacement. All these things you have to put along with the signs for particles moving along a straight line. If it is horizontal motion, motion along x-axis. If velocity is towards right, take it as positive. If it is towards left, take it as negative. Okay. And if acceleration is towards right, take it as positive. If it is towards left, take it as negative. That's like that you have to put signs. Okay. And displacement. What is displacement? Displacement, it gives you the distance of the final point from initial point. Magnitude of displacement. Okay. So if final point is towards right of initial point, then displacement is positive you should take. And if it is towards left of initial point, displacement is negative you should take. And one more formula, that is displacement during nth second is there. Okay. So what is displacement during nth second? Sn is u plus a by 2 into 2n minus 1. That is displacement during nth second. Nth second is a 1 second time interval. It is displacement during nth second in a particular second time interval. Okay. For example, it is displacement during 9th second, means it is between 9 seconds and 10 seconds. Okay. So these are the formulae we use when particle is going along a straight line with uniform acceleration. And if acceleration is 0, then particle goes with constant velocity. Then what is displacement? It is ut we use. S is equal to ut. Okay. Then some of the definitions we have done, I think, already. Average velocity and all those things earlier. What is average velocity? This is symbol for average. Average velocity is displacement by time. Average speed is distance by time. Distance by time. Okay. So we'll do problems. Okay, some questions. Head on, first question. A particle starting from rest. A particle starting from rest moves with uniform acceleration of 2 meters per second square. Uniform acceleration of 2 meters per second square. After 10 seconds, acceleration becomes 0. Acceleration becomes 0. After 10 seconds, acceleration becomes 0. Find displacement in 20 seconds. Find displacement in 20 seconds. Do it all of you. it and tell me. Right, all of you. Did you get answer? If you get answer, you can tell me. Otherwise, I'll do it. Okay. Now, let us say initially it is at some point O. What is its initial velocity? 0. And what is the acceleration? 2 meters per second square. Acceleration is there for 10 seconds. Okay. After 10 seconds, acceleration has become 0. So after 10 seconds, what happens? As long as there is acceleration, velocity will change. Once acceleration becomes 0, it continues to move with same velocity. Okay. So first 10 seconds, let us say it will reach point A at t equal to 10 seconds. Okay. Then what is displacement and what is velocity at A should find. Okay. So for first 10 seconds, what is initial velocity? 0. Acceleration 2. Time 10 seconds. You have to find final velocity and displacement. What is the formula you should use? V equal to U plus 80. If I use V equal to U plus 80, you'll get 20 meters per second. And V equal to U plus 80. Then for displacement, S is UT plus half it square. UT is 0, half it square. That's half into 2 into 100. That's 100 meters second. That is displacement. Okay. First 10 seconds. That is OA. This is 100 meters. And what is its velocity here? 20 meters per second. Now what happened? Acceleration has become 0. Now it continues to move with same constant velocity. Constant velocity. Okay. So what they have asked? Total displacement in 20 seconds they have asked. So first 10 seconds, it is over. Okay, elapsed. Next 10 seconds, you have to find displacement. First 10 seconds, you have got 100 meters with acceleration. Next 10 seconds, it is going with uniform velocity, no acceleration. Okay. So what is the formula we use for next 10 seconds? S is equal to UT. Whatever velocity it has acquired after 10 seconds, with same velocity continues for next 10 seconds. Okay. So S is UT. So what is displacement in next 10 seconds? 20 into 10. That is 200 meters. So it will reach some point B. This is 200 meters. That's okay. So what is total displacement in 20 seconds means? First 10 seconds 100 meters. Next 10 seconds 200 meters. So what is total displacement? 300 meters. The same direction. Okay. Followed? Any doubt? What is velocity here? 20 only. Any doubt? Any doubt? And if they ask average velocity, let us say, okay, what is average velocity? Total displacement by total time taken. What is total displacement? 300 meters. Total time taken? 20 seconds. So 300 by 20, that is 15 meters per second. That is average velocity. Okay. Average acceleration is final velocity minus initial velocity by time taken. Just average acceleration. In the earlier problem, what is final velocity? 20. What is initial velocity? 0. So what is average acceleration? 20 minus 0 by total time 20. That is 1 meter per second square. Okay. Any doubt? You can respond. If you have any doubt, you can ask. Or you can type there, I can see. You can unmute yourself and ask also. Follow? Let our next question. A vehicle is moving with a velocity u. A vehicle is moving with a velocity u. When brakes are applied, it travels a distance x before it stops. When brakes are applied, it travels a distance x before it stops. When brakes are applied, it travels a distance x before it stops. Find the stopping distance. Find the stopping distance of a vehicle. Find stopping distance of a vehicle traveling with 4u. Find stopping distance of a vehicle traveling with 4u when brakes are applied. When brakes are applied. Do it all of you. Are you listening, all of you? Try it, all of you. You can tell me answer. Whether you are trying or not, I am unable to understand. Okay, unless you respond, I cannot tell. You can unmute and ask, or you can chat. You can type there answer. Okay. Now let us say, what is stopping distance? If initial velocity of a particle is u, then when will it stop? When it retards, means when acceleration is opposite to direction of velocity. So when acceleration is in this direction, then it will travel some distance and stops. Final velocity becomes 0. And this is called stopping distance. That is called stopping distance. When brakes are applied, it will travel some distance and stop. Then what is the formula I should use? V square minus U square is 2s. Okay. So what is V square? 0 minus U square equal to 2a. A is negative because it is towards left into s. Okay. So what is s? U square by 2a. Okay. U square by 2a. So what is stopping distance of any particle or a car or any vehicle when it is retarding at A is given by U square by 2a. U square by 2a. And what is stopping time? Means after what time it will stop? We should use V equal to U plus 80. V equal to U plus 80. V is 0 equal to U. A is minus. Okay. So minus 80. So what is time? U by A. So after what time it will stop? Is U by A seconds. And what distance it travels before it stops? U square by 2a. So what distance it travels before it stops is directly proportional to square of initial velocity. What is the time after which it stops is directly proportional to velocity. So how many times velocity increases? Stopping distance increases square times if retardation is same. Okay. Retardation is same. Ready to follow? Any doubt? I can write the equation and do, for example, for this first car, what is initial velocity U? So what is stopping distance? X. And retardation is A plus. And what is stopping distance? X is equal to U square by 2a. Now for second car, what is initial velocity? 4u. What will be stopping distance? You have to find. Stopping distance, let us say S. Let us. Then what is the formula? U square by 2a. What is U? 4u. 4u whole square. 16u square by 2a. That is nothing but 16x. Okay. Stopping distance is 16x. So you can write like this equation and solve. Okay. But stop. Okay. Follow. Write down this. So stopping distance is 16x. Any doubt? Now stopping distance otherwise directly is proportional to U square. So if velocity become double, let us say 2u, then stopping distance become 4 times. Velocity becomes 4 times. Stopping distance becomes 16 times, 4 square. Velocity is tripled. Stopping distance become 9 times. How many times velocity changes? Stopping distance changes by square times. Okay. Square times. If velocity becomes 1/3, stopping distance becomes 1/9, like that. Okay. Ready? Follow? If you can remember such things, you can directly fast. You can do it faster. Okay. If it is U, it is X. If it is 4U, it will be 16x directly. Square times. If it is 3U, 9 times. If it is U by 2 means velocity is half. The stopping distance becomes 1/4. Like that. Okay. Follow? Any doubt? No response. Whether you are listening or not, also I don't understand. Okay, write down next question, similar question. Try out. A vehicle is going with a velocity U. A vehicle is going with a velocity U. When brakes are applied, a vehicle is going with a velocity U. Full stop. When brakes are applied, it travels S. It travels S. Before its velocity become 1/3. Before its velocity become 1/3. It travels a distance S. Before its velocity become 1/3. What further distance it travels before it stops? What further distance it travels before it stops? What is stopping distance? Is U square by 2a. U square by 2a, where U is initial velocity and A is retardation. And stopping distance is distance it travels until it stops. Okay, final velocity should become 0. Question is find what further distance it travels before it stops. Do it and tell all of you. Try. 1 minute and solve. And tell the answer, okay? You write the answer there. You can tell also, okay? Or you can type there. I can see. Okay. When there is an interaction, it will be better, okay? You are not interacting. Raised hand. Okay, you raised a hand, but you can directly unmute and talk also, I think. Or you can chat. Is it possible to unmute yourself? Hello? Any doubt? You can unmute Shiva yourself. Okay. What is initial velocity? U. Once brakes are applied, it will be retarding. So acceleration will be opposite to direction of velocity. Then what is the distance it has traveled before its velocity has become 1/3? Means it has become u by 3. U by 3. Displacement is S. And what further distance it travels before it stops? Means final velocity should become 0. Okay. Then what is the further distance? Let us say x. Okay. Throughout, acceleration is same. That is retardation is same. Okay. Let us say this initial point is A, this is B, this is C. Okay. Now, if I consider motion from A to C, if I consider motion from A to C, what is initial velocity? U. Final velocity 0. Stopping distance means what? Distance traveled until velocity becomes 0. Okay. Means what is stopping distance? If I consider motion from A to C is S plus X. S plus X. And what is initial velocity? U. Okay. U. So what is stopping distance? S plus X is U square by 2A. U square by 2A. Okay. Now if you consider motion from B to C, what is stopping distance? X. You should not consider motion from A to B. You also can consider a right equation. But this is not stopping distance because at B, velocity is not becoming 0. Okay. You can consider motion from B to C. If you consider motion from B to C, what is stopping distance? X. What is initial velocity? U by 3. Okay. So if I use same formula, what is stopping distance? X is equal to initial velocity square by 2A. What is initial velocity? U by 3. So U by 3 whole square. That is U square by 9 by 2A. So what you have to find? X you have to find in terms of S. So divide both the equations. Okay. Or you cross multiply 9. RHS is U square by 2A. Okay. So if you bring this 9 to LHS, what do you get? 9x. 9x equal to U square by 2A. S plus X is equal to U square by 2A. So RHS is same. Therefore, LHS should also be same. So S plus X is equal to 9XL. Okay. So X value you can get from here. What is X? S by 8. Okay. X is equal to S by 8. Follow? Any doubt? Any doubt? Explain again. Okay. Now, what is stopping distance? Let us say initial velocity if it is u. Okay. U. Retardation is a. Stopping distance means distance it has traveled until velocity becomes 0. That is s. This I have explained earlier. Okay. We should use v square minus u square is 2as formula. Okay. V square is 0 minus u square equal to 2 into minus a into s. And what is stopping distance? U square by 2a. So wherever there is a velocity u and there is a retardation, velocity at that point if it is u, it can be u or u by 3, whatever it is. Okay. Retardation is a. Then what is the distance it travels before it stops? Is velocity at that point whole square by 2a. That's all. Okay. That is called stopping distance. Now in this problem, what I have given, initial velocity of a car is u. Okay. Then brakes are applied. Then it retards. Okay. What is retardation? A. Then before its velocity has become u by 3, it has traveled s. That is the question. That is information given in the question. Okay. What further distance it travels before it stops? That is the question. Means from there, it is still retarding. It has not stopped. Okay. Velocity only has become 1/3. Means it has become u by 3. Then what is the further distance it travels and it will stop finally? That is the question. Okay. Now I have considered initial point is A, this point is B, this point is C. Okay. And throughout, what is acceleration? Minus A only. That is retardation is A. Now if you consider motion from A to C, what is the further distance it travels before it stops? That is the question. This further distance is x, let us. Okay. Now you consider motion from A. What will be velocity? Velocity at A is initial velocity. That is u. And where it is stopping? At C. Then what is stopping distance if you consider motion from A? S plus x. Then what is the equation? S plus x equal to u square by 2a. Okay. Similarly, if you consider motion from B now for same car, what is initial velocity? U by 3. And it is stopping here at C. Then what is stopping distance if I consider from motion from B to C is x. Stopping distance is x. What is initial velocity? U by 3. Then what is stopping distance? Initial velocity whole square by 2a. So if you consider motion from B to C, what is stopping distance? X is equal to u by 3 whole square by 2a. That is nothing but u square by 9 into 2a. Okay. If you bring this 9 to LHS, what happens? 9x here. So 9x equal to u square by 2a. Here, what is RHS? U square by 2a. Here also u square by 2a. So LHS should be same. So s plus x equal to 9x. From here, x value should be. So 8x is equal to s. X is equal to s by 8. Follow? Any doubt? Shiva? What is stopping distance? U square by 2a. Okay. Stopping distance means distance it travels until it stops. Follow? Huh? Shiva? Your time to explain again. Okay. Did you follow now? Okay, one more similar question I give, then you try and tell answer. Okay, similar question I give. Write down. A vehicle is moving with a velocity u. A vehicle is moving with a velocity u. A vehicle is moving with a velocity u. It travels 20 meters on application of brakes. Write down. On application of brakes. On application of brakes, it travels 20 meters. On application of brakes, it travels 20 meters. Before its velocity become 1/4. It travels 20 meters. Before its velocity become 1/4. What further distance it travels before it stops? Same question, okay, similar. What further distance it travels before it stops? Travels 20 meters I have given, I think, okay. Travels 20 meters before its velocity become 1/4. What further distance it travels before it stops? Completed? Anyone? Did you complete, anyone? Shiva has responded once, but others are not at all responding. So velocity become 1/4. So what is initial velocity? Assume it is u. Initial point is a. What is retardation? A. Small a. Now, before it reaches B, where its velocity become 1/4, that is u/4. It has traveled 20 meters, let us say. Then what is the further distance it travels before it stops? Let us say it stops at C. Final velocity becomes 0. This is some x you take or s you take, whatever it is. Okay, doesn't matter. Now, first of all, you should consider motion from A to C. A to C. A to C, what is stopping distance? 20 plus x. 20 plus x. And what is initial velocity? If you take motion from A to C, velocity at A is initial velocity. What is initial velocity? U. And what is retardation? A. Okay. And stopping distance? 20 plus x. So what is stopping distance? 20 plus x. Equal to u square by 2a. Initial velocity square by 2a. Okay. Next, we are considering motion from B to C. B to C. Then what is stopping distance? X. What is initial velocity? U/4. Retardation is same. Okay. Same a. Then what is stopping distance? X. Equal to, what is the formula? Initial velocity square by 2a. If you consider motion from B to C, velocity at B will become initial velocity. That is u/4. So u/4 whole square by 2a. U by 4 whole square means U square by 16, right? By 2A. That's what I mean. Now bring this 16 to LHS. You get 16x. So what is RHS here? U square by 2A. Here also U square by 2A. Because RHS is same, LHS should also be same. So 20 plus x is equal to 16x. So if you take it to RHS, 15x. 16x minus x is 15x. So what is x? 20 by 15. That is 5 into 4, 5 into 3. 4 by 3 meters. That is 1.33 meters. Okay. Any doubt? Any doubt? Okay. Our next question. Head our next question. A particle is moving along a straight line. A particle is moving along a straight line. Its velocity is varying with time as. A particle is moving along a straight line. Its velocity is varying with time as v equal to 8 minus 2t. Velocity is varying with time as v equal to 8 minus 2t. Find displacement of the particle. Find the displacement of the particle during 7th second. Find displacement of the particle during 7th second. Do it all of you. Right. Others, are you trying or not listening? Rakesh, Revan, Saida. I'm seeing names, but Manaswini. Any doubts? We complete anyone? Now for a straight line motion, if acceleration is constant, how velocity is varying with time? Velocity will vary, okay? How it varies with time? V equal to u plus at, okay? And what is displacement as a function of time? Ut plus half at square. These are the formulae, okay? So whenever they give velocity in terms of time or displacement in terms of time, and those equations, if they are comparable to these equations, then we can conclude acceleration is constant. Okay. These are the equations when acceleration is constant. So whatever function they give in terms of time, velocity in terms of time, or displacement in terms of time, if they are comparable to these equations, then we can conclude acceleration is constant. So in this case, velocity is given as a function of time. Now, is it comparable to this equation? Yes. What is power of time here? 1. Here also 1. Okay. Power of velocity here 1. Here also 1. Other two are constants, u and a. What is u? Initial velocity. A is acceleration. They are constants. They are constants if equation is comparable to this equation. Now, is it comparable to this equation? Yes. What is power of t? 1 here. Power of v 1. In this given equation also power of t is 1. Power of v is also 1. So these two equations are comparable. Means we can conclude acceleration is constant. Acceleration is constant. Now, if you compare this equation with this equation, what is u? Can anybody tell now? What is u?
8.
8. That's correct. And what is a?
2.
Minus 2. This is plus a, okay? Minus 2. Okay. So what is a? Minus 2. Did you follow this, all of you? Then, what is the question asked? Displacement during 7th second. Displacement in 7 seconds is not asked. Displacement during 7th second. Now, this is the formula for displacement in some time interval. 7 seconds, 6 seconds, 10 seconds like that. What is displacement during a particular second? 7th second, 9th second, 11th second like that. Okay. Or 6th second. That formula is displacement during nth second formula. That is u plus a by 2 into 2n minus 1. This formula I should use. What is the question asked now? Displacement during 7th second I asked. So here n equal to 7 you should put. U you know, a you know. Okay. So what is displacement during 7th second? U equal to 8. Okay. 8 plus a by 2. That is minus 1 I get. A is minus 2. Okay. So minus 2 by 2 minus 1 into 2n minus 1. What is n? 7. So 14. 2 into 7. 14 minus 1. 39. So what do you get? 8 minus 13. Minus 5 meters. Minus 5 meters. Followed? Any doubt? First of all, whatever equation they have given, is it comparable to the given equations, standard equations? You have to see. If it is comparable, we can conclude acceleration is constant. Okay. Hello. Hello. Any doubt? Okay, another question I'll give, similar question you try. Did you follow first of all this? You can type or you can speak. You are doing neither. Okay, next question. Write down. A particle is moving along x-axis. A particle is moving along x-axis. Its velocity is varying with time as v equal to 20 plus 3t. So velocity is varying with time as v equal to 20 plus 3t. But if I give t square here or v square here, it is not valid. Okay. What to do then? I'll tell. Okay. Comparing is not valid. Okay. V equal to 20 plus 3t. Write down question. Find displacement. Find displacement. Find displacement in 8 seconds. Find displacement in 8 seconds. Do it all of you and tell me the answer.
meters.
56 meters.
256, sir. 256.
256. Others also did you solve? Voice is not clear. Now, is it comparable to V equal to U plus 18? Yes. Okay. Now, if you compare, what is U?
20.
What is A? 3. Okay. Meters per second square. Then what is question asked? Displacement in 8 seconds. I did not ask displacement during 8 seconds. Displacement in 8 seconds. And what formula I should use? S is ut plus half displacement. Okay. Then what is S? You have to find. U is 20, A is 3. So if I substitute here, 20 into what is time? 8 plus half into 3 into 64. Okay. So this is 160 plus 96 on 256. That is correct. One student has told. What is your name?
Anita.
Okay, that is good. 256 meters. Okay. All right, our next question. Next question. Rakesh has given 496. It is not 496, okay? It is 160 plus 96. We should not use SL formula, okay? We should use S formula. S. S is ut plus half a square. Okay, calculation mistake. Okay, doesn't matter. Doesn't matter. Later I can correct. Okay, right our next question. Displacement of a particle moving along a straight line. Right on. Displacement of a particle moving along a straight line. Displacement of a particle moving along a straight line is given by S is equal to 60 plus 3t square. 60 plus 3t square. Find its velocity at the end of 7 seconds. Find its velocity at the end of 7 seconds. Try all of you.
$90 meters per second, sir.
90.
90 meters per second.
Okay. Now with what equation you have to compare this? With what equation you have to compare this? You have to compare with S is equal to ut plus half a square. Are they comparable? Yes. Because here one t term, one t square term. Here also same. Okay. So what is coefficient of t? Is u. That is initial velocity. So what is u? 6. And what is coefficient of t square? Is a by 2. Coefficient of t square is a by 2. So a by 2 is equal to 3. So what is a? 6 set. So a equal to 6 meters per second square. And what is initial velocity? 6 meters per second. Now what you should find? Velocity after 7 seconds. Now you know initial velocity, you know acceleration. And acceleration is constant. How do you find velocity after some time? What formula you should use? V equal to u plus a. What is u? 6. A is also 6. And what is time? 7. So 42 plus 6, 48 meters per second. Okay, followed? Any doubt? Any doubt? Followed? Okay. Read our next question. Velocity of a particle moving along a straight line, velocity of a particle moving along a straight line is varying with displacement. Velocity of a particle moving along a straight line is varying with displacement as v square equal to v square minus 25 equal to 4s. V square minus 25 equal to 4s. Find displacement of the particle during 4th second. Find displacement of the particle during 4th second. Do it all of you. Right. Now you can practice questions, and if you have any doubts also you can ask me. Okay. From kinematics, 1 dimension.
Meters, sir.
V square minus
12 meters. 12 meters. Yes, sir.
Huh?
12 meters, sir.
12 meters, okay. Others also need to try, all of you. Twelve is correct. So you should compare this with what equation?
V square minus u square equals to 2as.
Square minus u square equal to 2as. And what is u square? 25. So what is u? 5. What is coefficient of s? 2a. Here 4. So 2a equal to 4. So a equal to 2. Then you have to find displacement during 4th second. Then what is the formula? Sn equal to u plus a by 2 into 2l minus 1. Okay. What is u? 5. A by 2, 1. And n is 4. So 4 into 2, 8 minus 1, that is 7. So 5 plus 7, 12. 12 meters, that's correct. Any doubt? Any doubt? Any doubt? Okay, write down one more question. Work out at home. Tomorrow you tell me the answer, okay? Work out at home. Tomorrow you ask. Write down. A particle moving with uniform acceleration. A particle moving with uniform acceleration travels 12 meters. Travels 12 meters in first 3 seconds. Travels 12 meters in first 3 seconds. And 48 meters in next 2 seconds. And and 48 meters in next 2 seconds. 48 meters in next 2 seconds. Find the displacement of the particle in first 10 seconds. Find the displacement of the particle in first 10 seconds. Okay. So tomorrow I'll continue with problems. You try this question, tomorrow you tell the answer, okay?